Hello everyone, my name is Dan Hart. I'm a meteorologist with Open Weather, and today I'm going to be giving a presentation on atmospheric dynamics. We'll explore how the movement of air and atmospheric forces shape the weather we experience daily. Some concepts might seem technical, but I'll try to explain them in a way that's easy to understand. Atmospheric dynamics refers to how air moves and interacts within the Earth's atmosphere. This movement, influenced by several forces, creates everything from gentle breezes to powerful storms. In simple terms, it's the physics behind weather. Our atmosphere has 5 main layers, but for this presentation we're going to focus on the troposphere, where most of the weather occurs. Each layer has different characteristics, with the troposphere being the densest and closest to the Earth's surface. The troposphere extends from 7 to 20 kilometres above the surface, depending on the location and the season. It contains 75% of the total mass of the atmosphere, and there is a decrease in temperature with altitude due to the decrease in pressure and absorption of radiation by atmospheric gases. It's where most of the Earth's clouds and weather phenomenon occur. The boundary between the troposphere and the layer above it is known as the tropopause. So temperatures decrease with height in the troposphere due to the adiabatic cooling process, where rising air expands and cools as it moves into lower pressure environments, leading to a reduction in temperature with increasing altitude. The cooling of expanding air is primarily explained by the principles of thermodynamics, specifically the first and second gas laws and the ideal gas law. Air pressure is simply the weight of air pressing down on us. It decreases as we go higher up, like on a mountain. High pressure systems generally bring clear weather, while low pressure systems often lead to clouds and precipitation. Wind occurs when air moves from areas of high pressure to areas of low pressure, similar to water flowing downhill. The greater the difference in pressure, the stronger the wind. This is why storms can be so windy. They involve sharp differences in air pressure. Here's an explanation of why low pressure systems have different wind directions in the northern and southern hemispheres. The Earth spins like a giant top, which affects how things move across its surface. This spinning causes the Coriolis effect, which makes moving air, that is wind, turn to the right in the northern hemisphere and to the left in the southern hemisphere. In low pressure areas, air moves towards the centre to fill the empty space, but the Coriolis effect causes it to curve. In the northern hemisphere, this curving makes the wind move in a counterclockwise direction around low pressure systems. In the southern hemisphere, the wind curves in the opposite direction, moving clockwise around low pressure systems. This explanation captures the essence of how the Earth's rotation influences wind patterns differently in each hemisphere. The Coriolis effect is a result of the Earth's rotation. It makes moving air and water curve. This is why winds don't blow in straight lines, but instead spiral, such as in hurricanes or cyclones. Okay, let's imagine you're on a big merry-go-round that's spinning slowly. You and your friend decide to play catch. When you throw the ball straight to your friend, something weird happens. The ball doesn't go straight. It seems to curve to one side. This is kind of like the Coriolis effect on Earth. The Earth is like a giant merry-go-round, always spinning. When someone moves a long way across the Earth's surface, like wind or ocean currents, it looks like it's curving. The Earth's rotation is counterclockwise when viewed from above the North Pole, which means it spins from west to east. This is why the sun appears to rise in the east and set in the west. Our planet has 3 main wind patterns: trade winds, westerlies and polar easterlies. These winds play a big role in shaping our climate and weather pattern. For example, the trade winds help guide tropical storms across the Atlantic. Trade winds are steady, persistent winds that blow from east to west in the tropics, between approximately 30 north and 30 south. In the northern hemisphere, they blow from the northeast, and in the southern hemisphere, from the southeast. These winds are crucial for maritime navigation and play a key role in the Earth's heat distribution by moving warm tropical air towards the equator. Westerlies are prevailing winds found in the mid-latitudes between 30 north and 60 north and south in both hemispheres. They blow from west to the east. Westerlies influence weather patterns by driving ocean currents and are responsible for the movement of weather systems across the continents. Polar easterlies are cold, dry winds that blow from the polar regions towards the mid-latitudes. They blow from east to the west. These winds contribute to the cold climate of polar regions and can influence the development of polar fronts, which are boundaries between cold polar air and warmer air found in the westerlies. Jet streams are powerful wind bands located high up in the atmosphere. They are fast and can steer weather systems, like pushing storm fronts across continents. These streams can also impact air travel by either speeding up or slowing down planes, depending on the direction. Jet streams are typically found at altitudes between 8 to 15 kilometres above the surface, mainly in the troposphere and the lower stratosphere. There are two main types. First of all, polar jet streams. These are generally located 9 to 12 kilometres above sea level. Secondly, subtropical jet streams. These are usually a bit higher, around 10 to 16 kilometres above the surface. Jet streams are influenced by the Earth's rotation and temperature differences between equatorial and polar regions, helping to steer weather systems across the globe. Jet streams form primarily due to the temperature differences between polar and tropical air masses. When warm air from the tropics meets cold air from the poles, a sharp temperature gradient is created. This gradient causes a difference in air pressure, leading to strong winds. The Earth's Coriolis effect, due to the Earth's rotation, further influences these winds, causing them to flow in a westerly direction. As a result, jet streams are typically found in the boundaries of these air masses, such as the polar front and the subtropical regions, and they play a crucial role in influencing weather systems and the movement of storm systems. Cyclones and anticyclones are large-scale systems that greatly influence our weather. Cyclones form in areas of low pressure and can bring storms, while anticyclones form in areas of high pressure and usually bring clear skies. Descending air dries and warms due to several key atmospheric processes. First of all, adiabatic heating. When air descends, it is compressed by the weight of air above it. As the air is compressed, its pressure increases, which in turn raises its temperature. This process is known as adiabatic heating. The result is that as air moves downwards, it becomes warmer, regardless of the initial temperature of the air mass. Secondly, decrease in humidity. The increase in temperature leads to a decrease in relative humidity, as warmer air can hold more moisture than cooler air. This is why descending air tends to be drier. In summary, the combination of adiabatic heating, a decrease in humidity, and the presence of high pressure systems explains why descending air tends to be warmer and drier. Local winds, like sea breezes, are caused by temperature differences between land and sea. During the day, land heats up faster than the sea, causing air to rise over the land and cooler air from the sea to flow in, creating a breeze. Extreme weather events like hurricanes and tornadoes are the result of complex atmospheric dynamics. Hurricanes form over warm ocean waters, drawing energy from the heat. Tornadoes, on the other hand, are fast-moving columns of rotating air caused by specific conditions in thunderstorms. To sum up, the movement of air in the atmosphere, driven by various forces, creates the diverse weather we experience daily. While we may not notice these forces at work, they are constantly shaping our world and making life on Earth as we know it possible. Thank you very much for your attention.